Hey guys, in this video I'm gonna discuss the solutions for the Codeforces round 648. So let's start with problem C. So in the problem we are given two arrays A and B. Both are permutations of some n numbers. For example, array B can be array. So let's come to the problem. So the problem name was rotation matching. So let's see the first example. So the array A can be 1, 2, 3, 4 and 5, and array B can be 2, 3, 4, 5 and 1. So what we had to do in the problem was that we can rotate any of the arrays either left or right any number of times, and we have to find maximum matching pairs. So how can I solve this problem? So the brute force solution can be that we try out all the possible rotations in array B and find total matching pairs for each of the rotation and update our answer to maximum matching. So this is the brute force solution. So what will be the efficient solution here? So efficient solution will be, for example, we can see that these two elements are just one rotation further from this array, these all elements. One rotation means that these elements have a total distance of 1. For example, it have a total distance of 1, it have a total distance of 1, 1, 1, and it have a total distance of 1. Let's see another example. Let's say we have 1, 2, 3, 4, 5, 6, and we have 1, 2, 3, 4, 6 and 5. So in the array we can see that the distance of this one from this one is 4, because I'll rotate my array like this. So distance is 4, 1, 2, 3 and 4. So for the 1 I have a total distance of 4 here, and for 2 I have a distance of 1 and 2. For 3 I have a distance of 1 and 2. For 4 I have a total distance of 1 and 2, and for 5 I have a total distance of 0, and for 6 I have a total distance of 2. Now this distance means that we have to rotate our array like for 2 times to get to match the 2 with other 2. So we can just find the frequency of all these rotations and take the maximum of them. That will be our answer. For example, here the frequency of 2 will be 4, and frequency of 4 will be 1, and frequency of 0 will be 1. So I can see that among all these frequencies 4 is maximum, so our answer will be 4. So guys, this is the solution for problem C. So how can I implement this solution? What I can do is I can take two indexes array, index A and index B, and in index A I'll have indexes of all the elements of array A. So one will have index of 1, 1, 2, 3, 4, 5 and 6. So index of 2 will be 2, 3, 4, 5 and 6. Now in array B, the index of 1 is 3, and index of 2 is 6, index of 5 is 5, index of 5 is 5, and index of 4 is 2, index of 3 is 1, and index of 6 is 4. Now to calculate the distance, what I can do is I just subtract the, like in here I'll subtract 3 from 1, I'll get -2. I subtract 6 from 2, I'll get -4. Here I will get 2, here I will get 2, here I will get 0, and here I'll get 2. So now the negative can be made positive by adding just n. So -2 will become -2 plus 6 equals to 4, because negative means that the rotation is anti-clockwise, but we have to make it clockwise, so we just add n to it. And here -4 plus 6 will be 2. Now I can see that I get a frequency of 2 equals to 4, and frequency of 4 as 1 and 0 as 1. So my answer will be 4. Now let's discuss problem D. Problem D. So the problem D was solve the maze. Okay, solve the maze. So in the problem we are given a maze of n rows and m columns, and we have 4 characters here. The first character is empty, second character is wall, third character is good person, and the fourth character is bad person. So in the problem what we had to do was that we have to put, like we are given some initial condition of this maze. So let's say here I have 5 rows and 6 columns. So my initial condition could be like, here I have bad person, here also I have bad person, and rest are empty. Here I have good, here I have some hashtag, here I have wall, here also I have wall. This could be empty. So this can be one of the state that could be given in the problem. So what we have to do was put some walls in the empty spaces such that all the good persons can reach at this point n, m, and all the bad persons can't reach here. For example, if I put some walls here, now the bad person is blocked and good persons can come here because these are empty spaces. Now how can I solve this problem? So my first approach was just that if I can contain the bad person with just one wall on its boundary. For example, if I have a bad person, I just put walls around him like this so that it is blocked, and I'll do it for all the bad persons. And then what I will do is I just check if all the good persons can reach after putting these walls in some places. So now how is this giving me correct answer? So this is giving me correct answer because let's say if there was some good person here, so I cannot put a wall here, so I have to make this good person go at the final destination. Oh, that is a movie name. So I have to make this good person go to a destination, let's say here, and this person have to choose some path, but I can't put a wall here. So the total answer would be just no. And let's say the good person was bad person was here and good person was here. Let's say if good person had to, there was no way other but this way, that only after crossing this box he can reach the destination, but that means that bad person can also reach that destination. So our answer will be no again. So that's why this solution works. So what we have to do is, I'll just block all the bad persons and see if all the good persons can reach our destination. So this is my final solution. Now how can I, now this is easy, you can do this on your own, that you can block all the bad persons. How I can check if all the good persons can reach the destination in n into m complexity. So I can do this using DFS. Now how my DFS will work? So my DFS function is like this. Here I'll have row number and column number. So if row is less than 0, or column is less than 0, or row is greater than n, or column is greater than, I just return this is void. So I just return. Else what I can do is, I just take a map of pair of integer and bool. I name it visited map. So if I visit a row or column, I just mark it true, and or if I reach hashtag, I just return, or if I reach some bad guy, I just return. Now I also will have a good array, 2D good array, in which if I can reach without these all things, like if this is false and I don't have wall here, I don't have bad person here, so I'll just mark it 1, otherwise I mark all the good positions as 0. So 1 means that this is a good cell, bad persons can't reach here. So now after doing my DFS, what I will do is that I'll check for all the good persons if they can reach a good position, and if they can reach a good position, that means that they can reach to the destination. And in the main function I'll call my DFS from n comma m, and I'll just go from each cell to all the other cell for each DFS code. So this is the solution for problem D, guys. Now let's discuss the solution for problem A. So the problem E was the problem was that you have some elements, and you have to take, like you have to take a subsequence. Let's say the subsequence length is k. So if you have elements a1, a2, a3 dot an, you take some subsequence of this array, and let's say the subsequence length becomes k. Now you have to find some value for this subsequence. So the value would be that you will just sum 2 raised to power I if the ith bit is in at least k minus 2 positions. or if k is less than 2, then at least one element. So the ith bit should be set for at least k minus 2 elements of our subsequence. So this was the problem, and we have to find the maximum answer of this thing. How can I do this problem? So the first thing that came in my mind was that I'll just sort all the elements in decreasing order. So after sorting, I'll have a1 greater than a2 greater than a3 greater than ... an. But then I thought that if I take the first element and just iterate for all the pairs for these elements, because I knew that if I can make an answer for 3 elements, let's say a1 a2 a3, then the fourth element will not affect my maximum answer here, because if there is some bit, because we have to take at least k minus 2 elements, let's say there was a4. So if there is some bit that is only set in a1 and it is also set in a4, then my final answer won't change. Okay, and let's say if the bit was, if there is some bit that is set in a4 but not in a1 a2 and a3, so my final answer would not take that bit. So my final solution would be to check all the triplets and take maximum of my answer. So the final algorithm would be for I equals to 1 to n, and for j equals to I plus 1 to n, and for k equals to j plus 1 to n. I take my answer initially as 0, and here let's say I calculate local answer, which will be a of I or a of j or a of k. So I will update my answer as maximum of answer comma log. So this was very easy problem, guys, but I stuck on it for a while and it took me a long time to figure out this solution. Now let's discuss problem A. So problem A. So the problem A was here. The problem A was matrix game, and here in this problem we have a matrix of n rows and m columns, and unclaimed cells are represented by 0 while claimed cells are represented by 1. So if Ashish goes first, who will win? So the loser will be who is unable to make a move. Okay, and you can claim only a cell if there are no cells that if there are no cells in that row or column which are claimed earlier. So this is pretty easy problem, guys. So in this problem what we can do is that we can just mark -1 if I can't claim any cell. For example, if my initial array was like this, okay, let's check this array 1 0 0 0 0 0 and 1 0 0. So what I can do is I can just mark all the rows containing this block and column as -1. So I'll mark it -1 -1 -1 -1, and where comes 1 I'll not mark it because we are doing it for this one. So I'll have here 1. Now for this one I will just mark -1, so it will become -1 -1 -1. These are already marked, rest are 0. Now as Ashish was starting, so Ashish can just choose this box and he can win. So this problem was pretty easy. You just have to mark -1 on all the position that can't be obtained. So if Ashish choose this position, I'll just mark all the position -1 of this row and column. So I'll just mark it -1 and this also -1. Now Vivek have no option here and Ashish will win. So this was pretty easy, guys. Now let's discuss problem B. So problem B was trouble solved, and in this problem we have two arrays AI and A and B. Problem B. So we have two arrays A and B, and we have A array like 10, 20, 20, 30, 0, 1, 0, 1. So in the problem I have to sort my array A, and I can swap any elements that are that have B value different from each other. For example, I can swap 10 and 20 because their B values are 0 and 1s. So this is the problem, guys. Now the solution can be like this. So you just take all the elements which contains 0. So you take all the elements which contain 0 in one vector. You maintain two vectors C and D. So in C I will store 10, 20, and in D I will store 20 and 30. Now what I can do is, I can see that if these are already sorted vectors, my answer is already yes, because I can just merge these two vectors like this, because while merging I know that I can swap elements of C with D. I can swap any element of C with any element of D. So this was the solution, but there is some problem, guys. So my final answer would be like this. If I have an array C, and I'll just check in my array C and D that if they are both increasing, if they are both sorted, then my answer is yes. Okay, my answer is yes. But if they are not sorted, then I'll check if for example if C was not sorted, then I will just check if size of D was greater than 0. If it is greater than 0, then also my answer is yes. And I will do this for D. I will just check if elements in array D are sorted in increasing order. If they are not, then I will check if size of array C was greater than 0, because if size is greater than 0, for example, let's say C array was like this, 30, 10 and 20, so it is not sorted. And let's say I don't have D array, so I cannot swap the elements of this array, so I cannot sort this array, so my answer will be no. But let's say if D array had some element, for example let's say it had 5, so I can just swap this 10, swap the position of 5 with my 10 to get my sorted array. So that's it for this video, guys.